This is Chapter 7.2, Lecture Part 1. We'll take a look at what we worked on in the previous section, find the areas underneath the curve to solve probability problems. Now we're just going to do a lot of practice problems here to apply what we learned here. And so we're going to be basically applying, right, the normal distribution, properties of the normal distribution to answer some questions. So to begin with, we're going to go ahead and take a look at the top of our note sheet for section 7.2. And so what we're looking at here is to recall an idea that we've talked about before, which is a z-score. So you have to stop and remember now, retrieve that idea of what is a z-score. So practice that real quick. What is a z-score? You got it. A z-score tells us how far above or below a value is above the mean. And it's determined in terms of z-scores, or what we call standard deviations. And so you know the formula already. A next value minus the mean divided by the standard deviation tells you how many standard deviations above or below. It's a standardized way of measuring how well someone did relative to the mean. And now in this case, we're going to be using these z-scores to determine probabilities and proportions of people who are above or below a certain value, kind of like percentile questions. And so what we know now is this, is that when you calculate z-scores for data, what we know is that the z-scores, right, z-scores can be considered a random variable. And in this case, when we graph the values of z-scores for all data, instead of graphing the data, if we graphed the z-scores are going to be normally distributed. The mean would be 0 and the standard deviation equals 1. The random variable z is said to have the standard normal distribution. And so if we did z-scores for all this data, for any data that we had, the graph of z-scores would be a standard normal curve looking like this, and it would follow the same rules that we have, which is if how many standard deviations above or below it is, it's going to follow those same characteristics right here. So you'll see 68% are within one standard deviation and so forth. So for example, just to recall something, IQ scores can be modeled with a normal distribution with a mean of 100 and a standard deviation of 15. And so if an individual scores 120, he's 1.3 standard deviations above the mean. So what that means, again, if we had some curve like this here, and we drew the curve, here's the normal curve. This would be an example. These would be IQ scores, the relative frequency of people with and their IQ scores. We would know the middle. The middle is if we get the z-scores, right? These were the z-scores. Oops, misspelled that. These are the z-scores for IQs. If these were the z-scores for IQ scores, we would know the mean is 0, the standard deviation would equal 1, and so this person would be somewhere over here, the z value of 1.33. And with that number, we should then be able to predict what's the probability that someone scores more than 133 points on an IQ score. How would we do that? The way we would do that would be to find this area. And that answer here, the probability that someone scores more than 133 would be the answer to that area. Now, what we're going to show you right now is how to answer that question. How do I calculate that area if my z-score is 1.33? So think about how would we do? We don't have rectangles. This is a weird shape. I don't have a formula to plug into, but I do need to find this area to find out the probability of scoring higher than 120 on an IQ score, or getting a z-score of 1.33. Sorry, so that's not 133, it's 1.33. I apologize there. 1.33. Okay, what's the probability of getting a z-score greater than 1.33 on an IQ test, right? And so we would want to answer that question. And to answer that question, it's not a complex, it is a complex formula, but we're not going to use it. To answer that question, we would go to StatCrunch. And so your StatCrunch is open. I should have warned you beforehand. Pause if you need to do that. To answer that question, there's a normal calculator. Found it. There it is. Notice you get a normal curve. The mean is 0, standard deviation is 1, and I would put 1.33 in here. This is what we're going to do a lot of. What's the probability I score more than that? And the answer is 0.092. 0.092 would be the answer to that. And so what's the probability someone has a z-score greater than 1.33? The area turns out to be 0.902 or 9.02% chance. And so that's what we're going to do. That's it. And these instructions are right here in the previous page. Finding the area under the standard normal curve, what I just did, you'd find right here. Okay, so you'll refer back to that, but that's what I'm going to be using in these examples. So let's go ahead and answer these questions here. There's no context, it's just answering a question. So find the area under the standard normal curve. This is the standard normal curve. It's the z-scores. To the left of z equals negative 1.38. So for part A, you go ahead and draw a standard normal curve. Mean is 0. Standard deviation is 1. A z, so this is the z axis. Negative 0.38 is somewhere here. And so what we're looking for is this area right there. Find the area to the left. And so the answer for A, we're going to go to StatCrunch, get your standard. Let me show you one more time. Stat calculator's normal. My z-score, StatCrunch uses an X, so it doesn't change it, but it's our z-score wants to be less than negative 0.38. To the left or less than, and then compute. This is to the left, less than. I use the less than sign for left. Answer is 0.352. And then that's the answer for that. So A is equal to 0.352. That's the area. Let's go ahead and do B. Find the area under the normal curve to the right. Okay, so let's go do B. Here's our normal curve. You're going to get used to drawing a normal curve. Mean is 0, standard deviation is 1. Z equals 1.25 is somewhere right here. Let's go with a different color again. There is Z is equal to 1.25. And so to the right, so I'm looking for this area right there. What is that area equal to? In order to find that, this is going to be pretty simple. Just go to StatCrunch again. You're going to put in 1.25 here. And then we want this to be to the right. So then you put a greater than symbol, compute, and you get 0.106 would be the answer for this one here. 0.106. And so the area for B is 0.106. That's it. Well, again, there's no context here, so we're just practicing now. Find the area under the standard normal curve between negative 1.02 and 2.94. And so for C, I'm going to draw a normal curve. There's my z-axis. Going to go a little faster. We know the mean is 0. We want the area between here, negative 1.02, and way over here somewhere z equals 2.94. And so the answer for C, we go to StatCrunch again. And we're going to go use the between one. And in this case, I already forgot the values. So let's go a little back to look at that. Negative 1.02 and 2.94. And what I like is in StatCrunch, you get the actual normal curve and you get the picture. So we're trying to calculate, the red part is the area. And so 0.844 is our answer there. And so that's it. This is 0.844, the area between those 2 points. That's the area. And so the area equals 0.844 for C. That's it. We're going to go ahead and solve some problems in the next video.